In our last videos, we followed gold through an unusual journey. We looked at the strange shape some nuggets carry, why certain pieces appear compressed, rounded or untouched, and how some gold spends millions of years trapped inside rocks that seem unwilling to release it. We even followed the slow process nature uses to weaken those barriers until hidden gold finally begins appearing at the surface. But despite everything we discussed, one important question remained unanswered. If gold eventually leaves the rocks that once imprisoned it, why do experienced prospectors sometimes stop searching in the places everybody expects to find gold and instead spend their time examining locations that appear completely ordinary?
I had no idea.
Today, I'm going to show you a simple but surprisingly effective observation that many people unknowingly walk across every day. It isn't a detector setting. It isn't a secret chemical process. It isn't hidden inside a geology textbook. It's a pattern. And once you understand how this pattern behaves, you'll probably begin looking at certain landscapes differently for the rest of your life. Because this gold trick works in places most people ignore. And no, I'm not talking about rivers. I'm not talking about old mines. I'm not talking about desert washes. I'm not talking about exposed quartz veins. In fact, some of the best examples don't even look particularly attractive. Imagine walking across a gently sloping hillside after several weeks without rain. Everything appears dry. Most shrubs look healthy enough. The grasses are sparse. The soil seems uniform. Then something catches your attention. A narrow strip of vegetation looks slightly different. Not greener, not dead, simply behaving differently. Maybe its leaves appear smaller. Maybe its growth pattern changes direction. Maybe plants become more scattered. Perhaps one species suddenly dominates while neighboring plants disappear altogether. Most people continue walking. Experienced observers occasionally slow down because plants do not simply respond to sunlight. Plants negotiate constantly with the chemistry beneath their roots, and beneath some seemingly ordinary hillsides, the chemistry can be surprisingly unusual. Long before a prospector arrives, fluids carrying dissolved elements may have passed through fractures hidden deep below the surface. Those fluids do not always bring gold alone. They can modify the surrounding environment in subtle ways. They may alter soil chemistry, redistribute trace elements, change moisture retention, or influence microbial communities living within the upper few inches of ground. The result is fascinating. The gold itself remains invisible.
There we go, guys, look at this.
But the landscape quietly begins behaving differently. Think of it this way. Imagine hiding a powerful heater beneath a carpet. Nobody sees the heater. But people walking barefoot eventually notice that one section feels different. The heater is hidden. The effect is not. Gold systems occasionally behave in a similar manner. They don't announce themselves. They whisper, and the whispers often appear through patterns people mistake for coincidence. Now here's where things become interesting. Not every vegetation anomaly relates to gold. That would be too easy. Some reflect water availability. Some indicate clay-rich horizons. Some respond to buried debris. Some simply reflect natural ecological competition. The trick is recognizing persistence. Gold-bearing systems often leave remarkably stable signatures. They repeat, year after year, season after season. They don't disappear after one storm. They don't migrate 50 feet overnight. They quietly maintain their position because the conditions creating them remain below. Experienced prospectors sometimes return to locations months apart just to see whether these subtle patterns remain consistent. If they do, curiosity increases. But vegetation is only one clue. There's another. And once you notice it, it's difficult to ignore. Pay attention to how moisture disappears after rainfall. Most people simply see wet ground becoming dry ground. Experienced observers sometimes notice something different. Certain narrow zones dry unusually fast. Others remain damp longer than expected. Again, this doesn't guarantee gold, But it does suggest that the underground architecture beneath your feet may not be behaving uniformly. Some zones allow water to move more efficiently. Some impede movement, some preserve moisture, others drain rapidly, and hidden structural pathways capable of transporting mineralizing fluids millions of years ago can occasionally continue influencing how water behaves today. Think about that for a moment. A process that occurred tens of millions of years ago may still influence where dew disappears first on a cool morning. Nature rarely erases every fingerprint. Sometimes it simply buries them beneath layers of ordinary appearances. This is one reason experienced prospectors often spend as much time observing the landscape as they do digging. They're not hunting gold directly. They're hunting inconsistencies. They're searching for places where the landscape quietly breaks its own rules. Now imagine standing on a hillside where everything appears uniform except for one strangely barren strip cutting diagonally across the slope. No river, no obvious fault, no visible quartz, no exposed sulfides, nothing dramatic. Most hikers would walk straight through it. An observer trained to recognize subtle deviations might stop. They might kneel down, examine soil texture, observe root density, look for iron staining, notice whether insect activity changes, inspect the distribution of resistant fragments, and suddenly, a place that looked worthless begins telling a different story. This is perhaps one of the biggest differences between casual searching and professional observation. Gold is rarely the first clue. Behavior is, patterns are, relationships are. And once you begin searching for behavior instead of searching for gold itself, your field of view changes completely. You stop asking, where is the gold? And begin asking, why is this place behaving differently? Because sometimes the answer leads nowhere. But occasionally, it leads exactly where you hoped. And that's where our next discovery begins. The interesting thing about hidden gold systems is that they rarely announce themselves in a dramatic way. People expect gold to leave obvious fingerprints, bright stains, quartz veins, abandoned workings, visible nuggets. Sometimes that happens. But some of the richest concealed systems discovered in modern exploration were identified because somebody paid attention to things that initially appeared completely unrelated to precious metals. Let's imagine something. You're walking through an area you've crossed dozens of times before. Nothing changed. No flood exposed new material. No excavation disturbed the ground. No prospector recently visited. Everything appears exactly the same. Yet this time, you decide to slow down. You notice something unusual. The soil beneath your boots feels different, not softer, not harder, simply inconsistent. One step produces a dull, compact sound. The next produces a slightly hollow response. A few steps later, the texture changes again. Most people dismiss this immediately. But experienced observers sometimes become interested, because landscapes develop memory. Beneath apparently ordinary surfaces, hidden structures can influence compaction patterns for astonishing periods of time. Ancient fracture zones, deeply weathered alteration corridors, and decomposed mineralized bodies often break down differently than surrounding materials. Millions of years after mineralizing fluids stopped moving, the uppermost few inches of soil may still preserve subtle clues. And this is where one of the oldest prospecting habits quietly reappears. Experienced prospectors occasionally stop searching directly for gold. Instead, they search for disagreement, places where the landscape behaves differently from itself. If vegetation suddenly changes without an obvious reason, if moisture distribution seems unusual, if surface temperatures vary during similar sunlight conditions, if insects repeatedly favor one narrow strip while avoiding another, those inconsistencies become interesting. Not because they guarantee gold, because they suggest hidden architecture beneath the surface. Think about that. Gold rarely changes the color of the sky. Gold rarely glitters from a distance, but gold-bearing systems often reorganize entire neighborhoods underground. Water flow changes, chemical environments evolve, biological activity adapts, and the surface responds. Sometimes the response is so subtle that people unknowingly step across it for decades, which brings us to something surprisingly fascinating. Certain plants are far more sensitive observers than humans. Plants do not care about geology. Plants care about survival. They constantly negotiate moisture, trace nutrients, metal concentrations, root penetration, microbial relationships. And occasionally, their growth patterns reveal things hidden below. Not because they know gold exists, because they are reacting to conditions associated with environments capable of carrying gold. Now here's something that surprises many people. Even temperature can occasionally become a clue. Not because gold generates heat. It doesn't. But different subsurface materials absorb, retain, and release thermal energy differently. Imagine arriving early in the morning after a cool night. One section dries quickly, another remains damp. One patch warms faster, another lags behind. At first glance, it seems meaningless, until the same pattern repeats, again, and again, and again. Persistence is important. Gold systems occasionally hide behind persistent abnormalities, not dramatic abnormalities, quiet ones. This leads us to one of the biggest mistakes made by inexperienced searchers. People often chase obvious beauty. Bright quartz, large veins, shiny minerals, picturesque landscapes. Meanwhile, some of the most productive environments look disappointingly ordinary. They don't attract attention. They repel it. And that may actually be their greatest advantage. Because ordinary places remain undisturbed. Ordinary places remain underestimated. Ordinary places remain available to people willing to observe carefully. Now let's return to our title. Every step you took was over hidden gold. Can that really be true? In a surprising number of cases, yes. Not because every field contains gold, not because every hillside conceals a deposit, but because many mineralized systems occupy much larger footprints than people imagine. Gold itself may occupy only tiny portions. Yet the hydrothermal systems responsible for transporting it may influence hundreds of feet of surrounding material. The gold becomes the prize. The alteration becomes the messenger. And once you understand the messenger, the landscape becomes much more interesting. Suddenly, walking through nature changes. You stop asking, "Where should I dig?" and begin asking, "Why is this place behaving differently?" That question alone has quietly guided some remarkable discoveries, because hidden gold rarely introduces itself. It waits patiently, allowing moisture patterns to whisper, allowing vegetation to react, allowing soils to evolve, allowing temperature differences to persist, and waiting for somebody curious enough to notice. Now imagine standing in an apparently unremarkable clearing. No prospectors, no old mines, no quartz veins, no exposed mineralization. Just a place everyone else ignores. And perhaps that's the most exciting possibility of all. The next overlooked clue might not be waiting inside a famous mining district. It might be waiting beneath an ordinary path, beneath an ordinary hillside, beneath an ordinary patch of ground people crossed yesterday, and perhaps crossed today, without ever realizing what the landscape was quietly trying to say. In one of our most successful journeys, we talked about rock patterns that occasionally tell prospectors they're standing above something much more valuable than ordinary stone. But after thousands of viewers watched that discussion, another question quietly remained unanswered. What happens when several of those patterns begin appearing together? Because experienced prospectors rarely stop after finding one clue. They become interested when landscapes start repeating themselves. Today, we're going to follow some of the most overlooked combinations of rock behavior that can occasionally persuade professionals to slow down, kneel beside an ordinary outcrop, and start looking much more carefully. And surprisingly, one of those patterns isn't even inside the rock itself. In our previous videos, we watched gold remain imprisoned inside resistant host rocks for millions of years. We followed nuggets through ancient pauses in transport, learned that gravity occasionally becomes tired of carrying heavy particles farther downhill, and discovered that landscapes quietly preserve clues long after the original mineralizing system stopped functioning. We even found ourselves standing in places most people crossed without hesitation, simply because the environment behaved differently than expected. But perhaps the most useful lesson prospectors eventually learn is that gold almost never arrives alone. Gold travels with architecture. Gold travels with disturbance. Gold travels with repetition. And repetition is what today's discussion is really about. Imagine walking toward an outcrop that appears disappointingly ordinary. There are no dazzling veins reflecting sunlight, no abandoned workings, no detector hole, no iron-stained cliffs advertising their history from a distance. At first glance, there seems to be no reason to stop. Then you notice something subtle. Several fractures are running through the rock, but unlike random breakage, they maintain a preferred direction. They repeat themselves. Some terminate abruptly against another structure. Others appear reopened. The rock surface between them is slightly recessed, as though weathering has spent more time there than elsewhere. Most people keep walking. An experienced observer occasionally slows down, not because they see gold, because they recognize organization. Nature is remarkably inefficient at producing order accidentally. When rocks repeatedly fracture in similar orientations, when weathering consistently exploits certain pathways, and when alteration selectively weakens only particular sections of an outcrop, geologists become interested. Prospectors become interested. And sometimes, although certainly not always, those organized patterns are the first indication that fluids carrying dissolved minerals once negotiated their way through that piece of crust. Gold itself may be absent, but the pathways remain, and pathways occasionally tell better stories than gold ever could. Think back to our previous discussions. We spent considerable time following nuggets after they escaped their original hosts. Today, however, we're turning around and walking backwards through that story. Instead of asking where gold traveled, we are asking where gold once paused, where fluids once hesitated, and where rock masses still remember those ancient conversations. Because rocks have memory. Not memory in the human sense. Structural memory, chemical memory, weathering memory. A mineralized system can stop functioning tens of millions of years ago, yet its surrounding rocks may continue behaving differently today. Some become unusually brittle. Some weather into rib-like ridges. Some collapse into mosaics. Some preserve unusually competent blocks, while neighboring units disintegrate. And occasionally, several of those behaviors appear together. That is when professionals begin paying attention. Because finding one clue is interesting. Finding 4 clues occupying the same outcrop is something entirely different. And perhaps the most surprising aspect of all is that one of the strongest clues may not even belong to the rock itself. The reason experienced prospectors become suspicious when multiple patterns appear together is because mineralizing systems rarely leave behind only a single signature. They tend to disturb an entire neighborhood of rocks. Imagine 2 hillsides standing only a few hundred feet apart. Both are composed of similar lithologies. Both have experienced the same climate, the same rainfall, the same freeze-thaw cycles, and the same biological colonization. Yet one hillside appears strangely organized. Fractures seem denser, blocks weather differently. Small ledges persist where they should have disappeared long ago. The neighboring slope simply looks exhausted, reduced to loose rubble and soil. Most people would call that coincidence. Professionals occasionally call it a question worth asking, because rock masses that once accommodated mineral-bearing fluids sometimes retain unusual physical behavior long after those fluids disappeared. Certain fractures become silicified and resist weathering. Adjacent zones become chemically weakened and collapse more readily. Tiny compartments begin forming between resistant structures, producing a subtle pattern that can be recognized from surprisingly long distances. And this is where many prospectors make an important mistake. They search for obvious veins, bright veins, thick veins, continuous veins. Experienced observers often become interested in the opposite. Interrupted structures, broken repetitions, discontinuous ribs, fragmented panels. Because hydrothermal systems are rarely polite enough to construct perfectly straight highways through the crust. They negotiate. They exploit weaknesses. They encounter resistant blocks. They reopen older fractures. They abandon pathways. They reactivate them later. The result can resemble a mosaic, not artistic. Geological. Imagine looking down at dry mud after a lake evaporates. Numerous angular shapes become separated by interconnected boundaries. Now imagine that pattern preserved in rock and later exposed by erosion. Suddenly, the outcrop no longer appears random. It appears compartmentalized. And compartmentalization occasionally matters. Because fluids carrying dissolved silica, sulfides, carbonates, and sometimes gold itself do not distribute uniformly. Some compartments receive repeated injections. Others remain largely untouched. Some become hardened. Others weaken. Some weather into protruding ribs. Others recess. Years later, prospectors arrive. Most see ordinary stone. Some begin counting repetitions, not consciously, instinctively. How many parallel structures? How many reopenings? How many changes in resistance? How many transitions occur within 20 feet? Because landscapes rarely repeat complex arrangements without reason. Then another clue appears, one that surprises many people. The vegetation, not because gold feeds plants. It doesn't. But altered ground occasionally changes drainage behavior. Moisture lingers differently. Fine material accumulates differently. Root systems encounter varying resistance. Certain shrubs colonize first, others struggle. The result is not dramatic enough to impress tourists. It may simply appear as an oddly shaped patch of vegetation occupying a narrow corridor through an otherwise uniform hillside. Most hikers photograph scenery. Prospectors occasionally photograph questions. Why is vegetation behaving differently there? Why does the fracture density suddenly increase? Why does weathering become selective? Why do some blocks ring sharply when tapped, while neighboring rocks crumble beneath pressure? And perhaps more importantly, why are all these observations occurring together? Because one clue can lie. Two clues can mislead. Four clues occupying the same small area become considerably more difficult to dismiss. Now imagine kneeling beside an outcrop and running your hand across its surface. One section feels smooth, another section feels granular. One side fractures cleanly, another side resembles compressed sugar. You may not be touching gold, you may not even be touching mineralization, but you might be touching the footprint left behind by an ancient plumbing system that once moved enormous volumes of fluid through the crust. And plumbing systems are interesting. Not because they guarantee discoveries, but because gold is notoriously reluctant to appear where pathways never existed. That realization changes how experienced prospectors walk. They stop walking toward glitter. They start walking toward architecture, toward repetition, toward disagreement, toward places where landscapes seem unable to behave normally. And surprisingly, one of the most persuasive examples of that abnormal behavior isn't found inside veins, fractures, or outcrops at all. It is found in the shape of the ground itself. Because sometimes an entire hillside quietly advertises a geological story that most people never learn how to read. And perhaps that's where many experienced prospectors begin separating themselves from everyone else, because they eventually stop searching for individual clues. They start searching for networks. A network simply means several independent observations occupying the same piece of ground and quietly supporting one another. One of the most persuasive examples begins with what professionals occasionally call a ladder pattern. Imagine standing 50 feet away from an outcrop. Across the face of the rock, narrow fractures appear almost parallel to one another. They may not be perfectly straight. Some bend, some terminate, some overlap. But collectively, they resemble the rungs of an old ladder leaning against a wall. Then another set of fractures intersects them, not randomly, consistently. The two directions repeat themselves throughout the outcrop. Suddenly, the rock mass becomes divided into numerous compartments. Weathering behaves differently inside each compartment. Some remain competent, others soften. Some protrude, others recess. And occasionally, these intersecting pathways once represented zones where fluids repeatedly negotiated access through the crust. Prospectors become interested because pathways matter. Gold rarely chooses isolation. Gold prefers opportunities. Opportunities are created by permeability. Permeability is frequently organized, and organization leaves patterns. Another network that occasionally attracts attention resembles fish scales. At first glance, the outcrop appears chaotic. Upon closer inspection, however, fractures overlap one another in a repeating shingle-like arrangement. Each fracture partially obscures another. Each opening appears to have formed under slightly changing stress conditions. To most observers, these simply appear to be broken rocks. To experienced geologists, they may represent repeated episodes of crustal adjustment. Repeated openings, repeated fluid access, repeated opportunities for mineral deposition. Then comes perhaps the most overlooked arrangement, the zipper pattern. Imagine a narrow alteration corridor running through an otherwise resistant hillside. Along both sides of that corridor, small fractures branch outward at alternating angles. Left, right, left, right, almost resembling the teeth of a zipper. These structures occasionally develop because the crust rarely accommodates stress gracefully. Stress redistributes. New pathways appear. Old pathways reactivate. Mineralizing fluids exploit these weaknesses. Years later, erosion removes softer material. The architecture remains. And prospectors kneel down, not because they see gold, because they recognize a conversation preserved in stone. Perhaps the most visually persuasive network is what some field geologists informally describe as a spiderweb arrangement. A central structure occupies the middle. Numerous smaller fractures radiate outward. Secondary fractures intersect them. Weathering intensifies around intersections. Tiny recesses develop. Moisture lingers longer. Vegetation occasionally changes. Multiple clues begin agreeing with one another. And agreement is powerful, because landscapes occasionally lie. Single clues occasionally disappoint. But when fracture organization, weathering behavior, slope morphology, moisture retention, vegetation response, and structural repetition begin occupying the same hillside, professionals become considerably more reluctant to dismiss the possibility that something important once occurred there. Now, does that mean every ladder pattern contains gold? Absolutely not. Does every spider web arrangement indicate mineralization? Certainly not. Nature enjoys imitation, but prospecting was never designed to guarantee discoveries. Prospecting was designed to improve probabilities, and probabilities improve dramatically when observers stop chasing isolated clues and begin reading networks. Because gold systems are surprisingly generous, they rarely leave only one fingerprint. They disturb rocks. They disturb chemistry, they disturb weathering, they disturb topography, and they occasionally disturb biological behavior as well. The challenge isn't forcing the landscape to reveal gold. The challenge is learning to recognize when the landscape can no longer completely hide its past. And perhaps that is the most valuable lesson hidden inside today's discussion. In our previous journeys, we followed gold after it escaped from host rocks. We learned that landscapes occasionally preserve nuggets in places gravity forgot. We discovered that ordinary terrain sometimes protects extraordinary stories. Today, we took another step backward through that journey. We learned that before gold ever becomes a nugget resting beneath someone's boots, before erosion liberates it, and before gravity negotiates its transport, the surrounding rocks often spend millions of years quietly recording the pathways that once fed the entire system. Most people continue searching for glitter. Experienced prospectors increasingly search for memory. Memory preserved in fractures, memory preserved in repetition, memory preserved in patterns. Because sometimes standing above hidden gold has very little to do with seeing the gold itself, and everything to do with recognizing that the rocks beneath your feet still remember where it once traveled, and perhaps the next outcrop you pass won't appear quite so ordinary anymore.